Okay, now let's talk about significant figures. So basically, significant figures are the digits in a measurement that contribute to its precision. So basically, how repeatable is the measurement that we take? Like if we were to do it again, would we get the same answers? If we were to weigh something on the scale, would we get the same answers? So they include all certain digits plus the first uncertain digits. So here are the rules. All non-zero digits are considered significant. For example, in 123.45, each digit would be considered significant, so this would have 5 sig figs. Leading zeros are not considered significant. So in 0.0052, only the 52 is significant, so that would have 2 sig figs. Captive zeros, or zeros between non-zero digits, and trailing zeros, zeros to the right of the last non-zero digit in a decimal, are considered significant. So in 7004, 4 sig figs. And in 5.00, because there's a decimal, 3 sig figs. Trailing zeros in a whole number without a decimal point are not always considered significant. For example, in 1200, this would just be 2 sig figs. But if you have 1200 with a decimal, therefore 4 sig figs. So you need a decimal for the zeros to be considered significant, and the zeros in the beginning of a number are not, like 0.00, etc. So let's try figuring out how many sig figs there are in these examples. First one, there would be 1, because in 1000 there's no decimal, so as a result, just the first number is significant. In the second one, 1000.00, this would be 6, because there's a decimal, so everything is considered significant. 0.0024 would be 2, because leading zeros are not significant. 5.3001, this would be considered 5, because there's a decimal, everything is significant. 45 would be 2. 450 would be 2 as well, because remember, trailing zeros without a decimal are not significant. 450.0 would be 4. And 0.0001, this would just be 1. Now let's talk about the rules for multiplication and division with significant figures. When you multiply, you basically count how many sig figs there are in each number and then round to the lowest. So an example over here, 4.00 times 3, this would be 12.00, but when rounded to the correct number of sig figs, 3 and 1, we would just say 10. 4.56 times 3.572, this would have 3 and this would have 4, so we would give our answer to 3 sig figs, and 4.56 times 3.572 is equal to 16.288, and to 3 sig figs that would just be 16.3. Okay, next example, 7 times 14.2, 1 sig fig, 3 sig fig, 4 sig figs, so our final answer will just have 1 sig fig. So 7 times 14.2 divided by 15.78 gives you 6.299, but we just say 6 because 1 sig fig. So that's multiplication and division. When you're adding and subtracting, you look at however many numbers you have after the decimal, and you round to the one that has the fewest. So this one has 3, this one has 1. So our answer, once we do the addition, should just have one number after the decimal, 6.6. And this one, 5744, because this has 2 numbers after the decimal, this has 3, so our answer is going to have 2. So 4.48.